Hello there, Mr. Sutton here, bringing you the AB Calculus 514 Extra Practice Number 2 solutions on integration by substitution with indefinite integrals. To find this indefinite integral, I notice that I have a kind of an inner function here whose derivative, something involving an x, is elsewhere in the problem. So I'm going to try integration by substitution here. Let's let u equal -1 plus ln of 4x. So then I can write du equals the derivative of this, which is going to be, let's see here, this -1 is a constant, so that's just 0. Derivative of ln of 4x, that's going to be 1 over 4x times 4, so just 1 over x dx then. So we can write then that dux, or x du actually, equals dx. Substituting back into the original, we can write 1 over x times u, and then instead of dx we have x du. It looks like these x's are going to cancel, so really when the dust settles, this is just 1 over u du. And let's see here, we can take the antiderivative of this just using ln. This is going to be ln absolute value of u plus c. And if I substitute the stuff that u equals back in there, I end up with my final answer. On this problem, it would be difficult to simplify this in a way that would help us out. I noticed that we have a cosecant of 5x up here and a bunch of them down here, so maybe we could do something there. But something else I notice, I mean, we've got this inner function of cosecant of 5x whose derivative, cosecant of 5x, cotan of 5x, or something like its derivative, is elsewhere in the problem. So maybe some u substitution would help us out here. Let me let u equal cosecant of 5x. And then I can write du equals negative, and we have a tail of 5 here, so -5 cosecant of 5x, cotan of 5x, dx. And then dx is just going to be du over all this stuff that I'm not going to say again. There we go. All right, so let's try a little u substitution back into the original. I can write this as -10 cosecant of 5x, cotan of 5x, all over, and now this is going to be just u to the third power. Over here, instead of dx, we have this crazy du over expression. And what can we cancel out here? Well, we can cancel out the cosecant of 5x and the cotan of 5x. -10 over -5 gives us 2, so we have a 2 over u to the third power, which I could rewrite if I wanted to as 2u to the -3, and then that du is still hanging around. Using my reverse power rule, this bumps up to an exponent of -2. Dividing by that, we just have -u to the -2 power plus c for the antiderivative. And as one final step, let me just replace u with cosecant of 5x, giving us this answer. In doing this problem, I notice that I have an inner function, 4x squared plus 5, whose derivative, or at least something kind of like its derivative, is elsewhere in the problem, something with an x to the first power. So let me try substitution on this. So I can say u equals 4x squared plus 5. So then du equals 8x dx. And we can say that dx is really just du over 8x. Next, let me substitute back into the original. So I can write 24x cosecant squared of u, and then instead of dx, I have du over 8x. The 24x and the 8x cancel, leaving us with just a 3. We still have a cosecant squared of u du. Antiderivative of cosecant squared is going to be negative cotan, so this is -3 cotan of u plus c. And then if I substitute 4x squared plus 5 back in for u, I get this final answer. Well, this is just a crazy mess, isn't it? We have a whole lot of trig functions here, an explosion of trig functions. Some of them just have negative x's in them. Some of them have other trig functions in them. So I'm noticing here, since it's going to be difficult to simplify these because they have different things inside the trig functions, one thing I am noticing is that I have some inner functions, specifically these secant of negative x's here. And the derivative of secant of negative x, which would involve a secant and a tan, is elsewhere in the problem. So maybe I could try some u substitution on this to make things a little easier on myself. Let me start by letting u equal secant of negative x. That's the biggest inner function I can find here. If I take the derivative of this, I've got du equals, and now using the chain rule here, this is going to be negative secant of negative x, tan of negative x, dx. And then if I divide, I have du over all that stuff equals dx. Substituting back in, I can rewrite all of this as negative 4 secant of negative x, tan of negative x. That's still sticking around. But now we have cosecant of u, cotan of u, and instead of dx, we have du over that negative secant tan business. Okay, so this is the new situation. Things are going to get better soon, though, because these secant negative x's and tan of negative x's actually cancel out. So we really just have negative 4 cosecant of u, cotan of u du left over. And actually, it's going to be a positive because we had a negative down here and a negative up here canceling, so even better, just 4 cosecant of u, cotan of u du. Now the antiderivative of cosecant cotan, that's just going to be negative cosecant, so this is going to be negative 4 cosecant of u plus c. And then I'll just replace u with secant of negative x to get my final answer. For this problem, the key thing to pick up on is that we have an inner function whose derivative, also involving an e to the 3x, is elsewhere in the problem. So this is a good candidate for substitution. Let's let u equal this inner stuff of e to the 3x minus 2. So then du, using the chain rule, is going to be 3e to the 3x dx. So then du over 3e to the 3x is the same as dx. And going back and replacing some things, we can write 6e to the 3x times the square root of u, and then instead of dx, we've got du over 3e to the 3x. E to the 3x's are going to cancel out completely. 6 over 3 is just going to be 2, and I'm just going to rewrite this radical as an exponent. So we have 2u to the 1/2 power times du. That's our new integrand. Now I can just use my reverse power rule. This bumps up to an exponent of 3/2, which means we're multiplying by 2/3. This is going to be 4/3 u to the 3/2 plus c. And then if I just substitute e to the 3x minus 2 back in for u, like so, we end up with our final answer. For this problem, you could actually do this by expanding this cubic term and then multiplying the negative 9x squared by the results, but that's going to take a while. Given that I have an inner function here whose derivative involving an x squared is elsewhere in the problem, u substitution is going to be a lot faster on this one. So let me let u equal negative 3x cubed plus 1, and then I can write that the derivative, du, is going to be negative 9x squared dx. So then dividing by negative 9x squared, we have something that's equivalent to dx, du over negative 9x squared. Plug in stuff back into the original. I can write negative 9x squared times u to the 3rd power, and then dx is going to be du over negative 9x squared. Conveniently, these negative 9x squareds cancel out completely, leaving us with just u to the 3rd power du. Now I can use my reverse power rule. This bumps up to an exponent of 4. Dividing by that, we have 1/4 u to the 4th power plus c. And then I'll just replace u with negative 3x cubed plus 1 to get this back in terms of x, and I'm done. For this problem, I notice that I have an inner function whose derivative is elsewhere in the problem, so this is a good candidate for u substitution. Let me start by letting u equal this inner function of e to the x minus 4. So then du is just going to be e to the x dx. That 4 is gone because it's a constant. So then we can write du over e to the x equals dx. Substituting back in now, we have negative 3e to the x times the cosine of just u. And then we have, instead of dx, we have du over e to the x. E to the x's are going to cancel. This is just negative 3 cosine of u du. Antiderivative of cosine is sine. So this is then going to be negative 3 sine of u plus c. And then replacing u with the original here with the e to the x minus 4, we have negative 3 parentheses, or negative 3 sine parentheses e to the x minus 4 plus c as our final answer. On this problem, you have to be kind of careful because a lot of people are going to see cosecant and cotan together and think that they can just, use the antiderivative of cosecant cotan, which would be cosecant. But these are different exponents on each of these, so we can't just go ahead and do that. One thing I do notice here is that I can treat this cotan of 5x as kind of an inner function. The derivative of just cotan by itself is cosecant squared, which I see over here. So if I try u substitution on this, I might be able to untangle this thing. So let me start by letting u equal cotan of 5x. And then du is going to be negative cosecant squared of 5x times 5, so negative 5 cosecant squared of 5x dx. And then du over negative 5 cosecant squared of 5x is going to be the same as dx. All right, let's replace some things over in the original. I'm going to rewrite this as negative 10 cosecant squared of 5x times, and now instead of all this stuff, I'm going to write u to the third power. And then instead of dx, I've got du over all that stuff down there. It looks like these cosecant squared 5x's are actually going to cancel. That's nice. We also have negative 10 over negative 5, which is 2. So we have the much nicer looking expression 2u to the third du. Using the reverse power rule now, this new exponent bumps up to a 4. Dividing by that, we have 2 over 4, or 1/2, u to the fourth power plus c. And then I'll just go ahead and replace u with cotan of 5x. So I'm going to write 1/2 cotan to the fourth of 5x plus c. For this problem, I can't really simplify this trig function a whole lot, but what I do notice is that I have an inner function, sine of negative 3x, whose derivative, something with a cosine in a negative 3x, is elsewhere in the problem. So let me try substituting on this. Let's let u equal this inner function of sine of negative 3x. And then I can write du, the derivative, equals, let's see here, this is going to be negative 3 cosine of negative 3x dx. And then if I divide here, I've got du over negative 3 cosine of negative 3x equals dx. Substituting back in, I've got negative 12 cosine of negative 3x times, now we're going to have the cube root of u, and then dx is now du over negative 3 cosine of negative 3x. It looks like these cosine of negative 3x's are canceling. Good, I was tired of saying that anyway. We've got negative 12 over negative 3, that's going to be 4. So we have a 4, and we have a cube root of u, which I'm going to rewrite as u to the 1/3 power. So that's looking a whole lot nicer. Now this exponent, using the reverse power rule, this exponent bumps up to a 4/3, means we're multiplying by 3/4. 4 times 3/4 is just 3. So we have 3u to the 4/3 plus c. And then just substituting the sine of negative 3x back in there, we end up with this expression. Trying to find this indefinite integral is kind of daunting at first, but if you stare at this long enough, you may notice that we have an inner function, secant of negative 5x, whose derivative, this secant tan business here, is elsewhere in the problem. So we can try u substitution on this. So let's let u equal secant of negative 5x. So then du is going to be negative 5 secant of negative 5x tan of negative 5x dx. And then if I divide by all of that stuff that's not dx, I can get du over all that as something equivalent to dx. So now going back with all that to replace some things in my original, I still have this 20 secant tan term here, but now I've got e to the u, and instead of dx, I've got all this craziness with the du fraction. Let's see what happens now. This kind of looks worse than what we started with, but it's always darkest before the dawn, as they say. So it looks like the secant of negative 5x and tan of negative 5x, those are going to cancel out. I still have a 20 over a negative 5. That's going to be negative 4. We still have e to the u and du, so negative 4 e to the u du is the much nicer looking integrand that we are now dealing with. Antiderivative of this with respect to u is just going to be negative 4 e to the u plus c, which is very nice. And let's go ahead and substitute this secant of negative 5x back in for u just to get an answer in terms of x. And there we are.